Hi, welcome to part 2 of the ECG teaching videos. I'm Angie, thank you for watching. So in this video, we will teach you how to count the heart rate on an ECG and how to tell if the heart rhythm is regular or irregular, and how to tell if there is axis deviation and what axis deviation actually means. Step 1 is to figure out what the heart rate is from an ECG. It's usually printed at the top of the page, but it's useful to know how quickly to figure out the heart rate when the printed number is less reliable, like if a patient is in fast atrial fibrillation. The first method is to use the medium boxes, which are represented by this square here. The rate is 300 divided by the number of medium boxes or squares like this between each R wave. So in this case, there is half of one here, 1, 2, 3, and another little half. So we'll call that 4. 300 divided by 4 is 75. So the heart rate here is 75. This might be a bit tricky in a pinch. So the other option is to multiply the number of R waves on the lead 2 rhythm strip by 6. So a standard 12 lead ECG should capture information for 10 seconds. If you are using the normal settings, multiplying these R rates by 6 gives you how many beats happen in 1 minute. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a little bit here. So 12.5 multiplied by 6, it gives you 75 as well. So that is the heart rate. The next step is to check if the rhythm is regular or irregular, and there's no easy way other than to use the old-fashioned paper and pencil method. Get a piece of paper, place it over the lead 2 rhythm strip at the bottom, and draw a dot over each segment of R wave, maybe over 3 or 4 of them, and then move your sheet of paper down the line, and it should line up each of the dots with each of the R waves as you move across if the rhythm is regular. If it does not, then you have an irregular rhythm. Step 3 is axis interpretation. The axis of the heart describes the overall direction of travel of the electrical impulses in the heart. So if you remember from video 1, the electricity should move from the SA node to the AV node through the bundle of His and down the bundle branches, right and left here, all the way down to the apex and then up the Purkinje fibers on the right and the left. Sorry, the right and the left. And if you stand here at the apex of the heart, you should see the majority of the electrical energy coming your way. This is a normal axis. In some conditions, such as left ventricular hypertrophy, cardiomyopathy, and heart failure, the left side of the heart enlarges, and actually the apex sort of changes and moves a little bit towards the left. And what that happens then is that the electricity coming down the heart will actually change direction, and instead of coming straight down here to be seen over here, it maybe comes a little bit off to the side here towards the left, and what that means is that you have left axis deviation. The same thing happens on the right side in conditions that affect the right side of the heart, such as a pulmonary embolus or chronic pulmonary hypertension. And what you then get is the right side of the heart enlarges, and the signals goes from the SA node to the AV node down the bundle of His, and then actually instead of coming down towards the apex down here, it might come a little bit this way towards the right, and that is right axis deviation. So how do you tell if the axis is deviated on the ECG? This requires you to look at lead 1 and lead AVF. In each of these leads, the R and S waves, remember QRS complex, can either be positive, where the R is bigger than the S, equiphasic, where R and S are about the same, or negative, S is bigger than the R. Very simply, lead 1 looks towards the left side of the heart, towards the armpit on the left, and lead AVF looks towards the feet, or toward the right. I try and remember F for feet. And the positive complexes are going towards the lead you're looking at. So if you have positive complex in lead 1, which means the R is bigger than the S, and the same in lead AVF, that means the electrical signals are going towards lead 1 and towards AVF in the same sort of direction. So lead 1 this way, lead AVF this way, and equally in both directions. So that is a normal axis. If the complexes are positive in lead 1, so more towards lead 1, but negative in lead AVF, so going away from AVF, then this is more likely to be a left axis deviation. Finally, if the complexes are going away from lead 1 or going away from the left and going towards lead AVF with positive complexes, which is going towards the right, that means there is right axis deviation. So let's practice. Let's look at lead 1 over here. So this is the QRS wave. S is bigger than R. So this is a negative deflection. And then down here on AVF, you can see that the R is bigger than the S, and that is a positive deflection. Because lead 1 is negative and lead AVF is positive, this is a right axis deviation because the complexes are going towards AVF, which is the right, towards the feet. Next, we look at lead 1 again, and here, this time, the R is much bigger than the S, so this is positive. Then you look at AVF here, you can't really even see the R wave, and you can see the S wave is quite deep. So more of the charge is moving towards lead 1, which is towards the left, and that is left axis deviation. Here, we have both a positive lead 1, R bigger than S here, and a positive AVF, R bigger than S over here. And so this is a normal axis because both of these are positive.